morning, students. Let us start with today's discussion on the topic some basic concepts of chemistry. So today we are going to discuss calculation of percentage composition, empirical and molecular formula, relationship between empirical and molecular formula, and some calculation based on that very topic. So let us proceed. So first is calculation of percentage composition by using formula. So as we are knowing, the percentage of any element or constituent in the compound is the number of parts by mass of that element or constituent present in 100 parts by mass of the compound. It can be calculated by the following two steps. First is calculate the molecular mass of the compound from its formula being given by adding all the atomic masses of the elements present. Second one is calculate the percentage of the element or constituent by applying the following relation, that is percentage of the element or constituent will be equals to number of parts by mass of the element or constituent divided by molar mass of the compound into 100. You must have done this very formula in class 9th. So let us do one question based on that topic. You have to calculate the percentage of various elements present in MgSO4, that is magnesium sulfate. What are the elements present in that very thing? Magnesium, sulfur and oxygen. So you have to find one by one, find out percentage composition of each element present in magnesium sulfate. So for finding it out, first we have to find out the molar mass of magnesium sulfate. So it is coming 120. So after that, applying the formula, percentage of magnesium will be equals to number of parts by mass of magnesium divided by molar mass of magnesium sulfate into 100. So here one magnesium atom is present, element is present. So Mg having mass 24 divided by 120 will be the molar mass into 100. So it is coming 20%. For again similarly for sulfur and oxygen, for sulfur again we are having one element, one sulfur, so that is 32 divided by 120 into 100. So we are getting 26.67%. Similarly percent for oxygen, here we are having 4 oxygen atoms. So 4 into 16, each oxygen element having 16 gram atomic mass. So 4 into 16, that is 64 divided by 120 into 100. It is giving 53.33%. So this is the percentage composition. So let us proceed further towards our next topic, that is empirical and molecular formulae. We know that the formula of water is H2, while that of sulfuric acid is H2SO4. Similarly, formula of carbon dioxide is CO2, ammonia is NH3 and so on. So thus, a formula is a symbolic representation of one molecule of the substance which tells the number and kinds of atoms of various elements present in its molecule. So now the question arises is like this: how are these formulas determined? Means the determination of these formula of a substance involves first the determination of its empirical formula and then molecular formula. So let us now explain what we mean by these different types of formulas and the method of their calculation. So first one is empirical formula. So it is defined as the empirical formula of a compound is the chemical formula which expresses the simplest whole number ratio of the atoms of the various elements present in one molecule of the compound. So for example, the empirical formula of benzene is CH and that of glucose is CH2O. This suggests that in the molecule of benzene, one carbon atom is present for every one hydrogen atom. In the molecule of suppose we are taking now again second formula, we are taking glucose. So in the molecule of glucose, one atom of carbon is present for every one atom of oxygen and 2 atoms of hydrogen. So thus the empirical formula of a compound represents only the atomic ratio of the various elements present in its molecules. So next is molecular formula. So the molecular formula of a compound is the chemical formula which represents the true formula of its molecule. It expresses the actual number of atoms of various elements present in one molecule of the compound. For example, again we are knowing the molecular formula of benzene is C6H6, glucose is C6H12O6. For hydrogen peroxide it is H2O2. So this suggests that one molecule of benzene contains 6 atoms of carbon and 6 atoms of hydrogen. One molecule of hydrogen peroxide contains 2 atoms of hydrogen and 2 atoms of oxygen. And similarly for glucose, 6 atoms of carbon contains 12 atoms of hydrogen and 6 atoms of oxygen. So this is empirical formula and molecular formula. So there is some relationship between empirical and molecular formula. The molecular formula of a compound is a simple whole number multiple of its empirical formula. So mathematically we can write molecular formula is equals to n into empirical formula, where n is any integer such as 1, 2, 3, etc. So when n is equals to 1, then molecular formula will be equals to empirical formula. When n is equals to 2, molecular formula will be equals to 2 into empirical formula, and so on like this. So n we can calculate by using the formula given, molecular mass divided by empirical formula mass. So this, using these very formula we can find out the empirical formula as well as molecular formula. So let's proceed further. So let us discuss some questions based on empirical formula and molecular formula. How we are able to find out empirical formula by using the given data. So let us discuss the first question. The first question is like this. An inorganic salt give the following percentage composition. Sodium given is 29.11, sulfur given here is 40.51, and oxygen given here is 30.38. So you have to calculate the empirical formula of the salt given. Empirical formula of the salt. So for finding out the empirical formula of the salt, we have to draw these things. You have to find out these things using by drawing this table. So you can see from your table, the first column is for element. In the first column we are going to write the elements present in the given salt sample. We are not knowing the formula of the salt. So for finding out the formula, first of all, first column is for, we have to write down the elements, sodium, sulfur, oxygen. Next one you have to write symbols. Sodium is Na, sulfur S, oxygen O. Now we have been given, what other data been given to us? Percentage of element, that is for sodium 29.11, sulfur 40.51 and oxygen 30.38. After that we are knowing the atomic mass of each element for sodium, sulfur and oxygen. So after that we have to make 3 more columns, that is for finding out calculation of relative number of moles, that is number of moles, which is being calculated by using percentage given by atomic mass. So you can see over here percentage, like for example percentage given for sodium is 29.11 and mass is 23. So after dividing we are getting 1.266. Again for sulfur we are dividing 40.51 divided by 32. So we are getting again 1.266. Similarly for oxygen we are getting 1.897. So out of these number of moles, now for finding out the simplest molar ratio, what we have to do, we have to select that one which is the lowest number of moles. So here the lowest number of moles is 1.266. So we have to divide the lowest number of moles to each one of the number of moles for finding out the simplest molar ratio. So for first one 1.266 divided by 1.266, we are getting 1. Similarly for sulfur, we are getting 1. But for oxygen, we are having 1.897. So we have to divide the lowest number of moles, that is 1.266. So after that, we are getting 1.5. So now we have got simplest molar ratio. So after finding out simplest molar ratio, we have to find out simplest molar ratio in terms of whole number. So we have to convert this ratio in terms of whole number. So for converting this ratio in terms of whole number, what is the smallest number by which we can multiply these simplest molar ratio to get a whole number? So if we are going to multiply 1.5 into 2, we are getting 3. 1 into 2, we are getting 2. 1 into 2, we are getting 2. So this is the smallest number 2, which we are going to multiply with simplest molar ratio to get the simplest whole number molar ratio. So after getting the whole number, now we are knowing that we can write the empirical formula of the given salt. So for writing, first means sodium Na2 S2O3. So this will be the empirical formula of the given salt. So I hope you have understood how to find out the empirical formula of the given salt. So let us discuss one more question to get it more clear, and in that very question we will able to find out the molecular formula as well. So the next question is like this. A compound contains 4.07% hydrogen, 24.27% carbon, 71.65% chlorine, and its molar mass is being given, means the salt molar mass being given to us. So if in the question it's been given to us, only then we are able to find out the molecular formula. In the previous question, the molar mass is not been given. So after this we have to find out what are its empirical and molecular formulas. So again we have to draw, we can draw it in tabular form, or else we can directly do it, solve it in tabular form. It will be easy to calculate and to get the formula of the compound faster. So again draw that table. Element, here element present is carbon, hydrogen and chlorine. So carbon symbol you are knowing, percentage of element being given to us, carbon is 24.27, 4.07 for hydrogen and 71.65 for chlorine. Atomic masses you are knowing, for carbon 12, hydrogen 1 and chlorine is 35.5. So now our next work is to find out the relative number of moles. So for finding out the relative number of moles, we have to divide the percent of element divided by atomic mass of the given element. So here percentage been given. So for finding out moles, relative number of moles of carbon, so we have to divide 24.27 divided by molecular mass, means the atomic mass of element, that is 12. So we are getting number of moles is 2.02. Again for hydrogen we are doing the same thing and we are getting number of moles 4.07. Similarly for chlorine we are getting 2.02. So now we have got the total number of moles of each element. Now after getting this one, we have to first find out which among these is the lowest number of moles. Obviously it is 2.02. So again we have to do, for finding out the simplest molar ratio, what we have to do? We have to divide the number of moles, relative number of moles by the smallest number of moles among these. So again we are doing the same thing, 2.202 divided by 2.02, we are getting 1. Again for hydrogen we are having 4.07, the relative number of moles divided by the lowest number of moles, that is 2.02. So we are getting 2. So now for third one, 2.02 divided by 2.02, we are getting 1. So students, now you can observe from here that here we have got all the integral numbers, all the whole numbers. We have not got the numbers in fractions or decimals. Like in previous one we are getting 1.5 after dividing, but here we are getting 1 to 2. So no need of again multiplying with another smallest numbers. So we are multiplying simply by 1. 1 into 1 1, 2 into 1 2, 1 into 1 by 1. So we are getting the whole numbers at this very part, and after getting the whole numbers we can write the empirical formula of the compound, which is CH2Cl. Okay, that is from here carbon 1, hydrogen 2, chlorine 1. So now we have got empirical formula. So our second work is to find out the molecular formula. And as we have discussed, the relationship between them is molecular formula will be equals to N into empirical formula. And N can be calculated by using that very formula, that is molecular mass by empirical formula mass. So molecular mass is being given over here, that is the molar mass 98.96. And empirical formula mass we can calculate simply for carbon 12, hydrogen 2 into 1 plus 35.5. So it is coming 49.5. So after dividing both of them we are getting 2. So N we have got here, that is 2 small n into CH2Cl2. So after multiplying it we are getting the molecular formula C2H4Cl2. So these are the empirical formula and molecular formula calculations based on the given data. Okay, I hope you have understood these questions properly. Students, today we have discussed about calculation of percentage composition, empirical and molecular formulae and relationship between them, along with there are some calculations based on these topics. I hope you have understood the topics and try to solve some more questions based on empirical and molecular formula. Thank you, students.